Collaborative Combat Aircraft CCA program has crossed a key landmark. General Atomics YFQ-42A fighter drone prototype has officially taken to the skies, marking a major step forward in the U.S. Air Force's CCA program. The YFQ-42A is one of two designs competing in the program's first phase, known as Increment 1, alongside Anduril's YFQ-44A. The U.S. Air Force and General Atomics Aeronautical Systems, Inc., GA-ASI, announced the achievement, though the exact date of the maiden flight has not been disclosed. This milestone follows the Air Force's announcement in May that both the YFQ-42A and YFQ-44A had entered ground testing in preparation for their initial flights. In this video, Defense Updates analyzes why first flight of General Atomics YFQ-42A is a move to next-gen warfare. Before we proceed, a word on NordVPN, which is one of the most trusted and fastest VPN brand that has a no-log policy validated by Deloitte. NordVPN provides a 256-bit encrypted tunnel that protects your privacy and also enables you to access contents that are blocked based on geolocation. Its threat protection system helps you avoid phishing, scams, and malware. NordVPN application is available for all the major platforms as well as browsers. Get an exclusive NordVPN deal with massive saving by going to nordvpn.com/defense or clicking the link in the description. It's risk-free with Nord's 30-day money-back guarantee. The main goal of the U.S. Air Force's Collaborative Combat Aircraft CCA program is to field a new class of affordable autonomous or semi-autonomous drones that can operate alongside manned fighters like the F-35 and the future next-generation air dominance NGAD aircraft. Instead of replacing human pilots, CCAs are meant to act as force multipliers, taking on high-risk missions such as electronic warfare, intelligence gathering, strike, and air-to-air engagements, while keeping pilots out of immediate danger. The Air Force envisions CCAs as loyal wingmen that can extend the reach, survivability, and lethality of manned aircraft. In April 2024, the U.S. Air Force announced that it had picked General Atomics and Anduril to build actual prototypes of their Increment 1 CCA designs. This drone is designed for semi-autonomous air-to-air operations and builds on the XQ-67A off-board sensing station. Its autonomy core, developed through years of MQ-20 Avenger flight testing, supports a modular, software-driven approach intended to allow upgrades throughout its service life. Secretary of the Air Force Troy Mink said in a statement, "This milestone showcases what's possible when innovative acquisition meets motivated industry. In record time, CCA went from concept to flight, proving we can deliver combat capability at speed when we clear barriers and align around the warfighter." GA-ASI's President David R. Alexander said in a separate statement, "What a great moment for the U.S. Air Force and for GA-ASI. It's been our collaboration that enabled us to build and fly the YFQ-42A in just over a year. It's an incredible achievement, and I salute the Air Force for its vision, and I salute our development team for delivering yet another historic first for our company." Dr. Jason Levin, Senior Vice President of Engineering, Air Dominance, and Strike at Anduril said, "Flight test is one of those milestones that you just can't help but get excited about, no matter where you sit. Congratulations to General Atomics and the U.S. Air Force for kicking off flight testing for YFQ-42A, a major milestone on the path to fielding Increment 1 CCAS by the end of the decade." The U.S. Air Force has reaffirmed that it intends to make a competitive Increment 1 production decision in fiscal year 2026, which begins on October 1st. At that point, the service will determine whether to proceed with production variants of the YFQ-42A, the YFQ-44A, or potentially a combination of both designs. Under Increment 1, officials anticipate ordering between 100 and 150 drones, though this represents only the initial step in a much broader effort. The Air Force ultimately envisions acquiring at least 1,000 collaborative combat aircraft CCAs through multiple iterative development cycles, each of which could produce very different designs. Senior leaders consistently describe the CCA program as a cornerstone of the service's future force structure, arguing that these autonomous aircraft will be indispensable in future high-end conflicts. particularly a potential showdown in the Pacific against China. Air Force Chief of Staff General David Alvin said in a statement around announcement about the YFQ-42A's first flight, "This is more Air Force in action. We're not just moving fast, we're learning fast." CCA will help us rethink the battle space, extend reach, flexibility, and lethality in combat operations, and optimize warfighter performance through human-machine teaming. While many challenges still lie ahead before the CCA program can deliver the game-changing capabilities the Air Force envisions, but with the YFQ-42A now in the air, the service has taken a significant step closer to turning that vision into reality. The shift towards CCA reflects the profound changes taking place in modern air warfare, where contested skies, dense air defense systems, and the rise of peer adversaries demand new solutions that go beyond the capabilities of manned fighters alone. Traditional platforms like the F-35 or upcoming sixth-generation jets are powerful but costly, and operating them deep inside heavily defended airspace exposes pilots to unacceptable risks. CCAs answer this challenge by combining manned aircraft with a fleet of unmanned wingmen that can assume high-risk tasks such as suppression of enemy air defenses, electronic attack, or strike missions, thereby safeguarding pilots while multiplying combat power. The cost advantage is central to the appeal. Instead of procuring large numbers of prohibitively expensive fighters, air forces can deploy lower-cost drones as force multipliers, configured for different missions through modular payloads. Surveillance pods for intelligence collection, jamming equipment for electronic warfare, or precision munitions for strike operations. This adaptability allows commanders to tailor formations to the mission at hand, something a rigid fighter fleet cannot easily achieve. At the same time, CCAs enable swarming and saturation tactics, where multiple drones overwhelm defenses by sheer numbers, forcing adversaries into unfavorable cost exchanges and opening gaps for manned aircraft to exploit. The development of artificial intelligence and autonomy further strengthens this model, as drones can operate semi-independently, navigate in formation, detect threats, and share data in real time, reducing the cognitive load on human pilots who shift from direct operators to mission commanders. These innovations prepare militaries for the realities of great power conflict, where communications may be degraded, contested domains are the norm, and survivability requires distributed, resilient systems rather than reliance on a handful of exquisite platforms. Beyond the tactical and operational benefits, CCAs also serve strategic purposes. They raise the deterrent value of air power by presenting adversaries with the prospect of facing not just a few manned fighters, but swarms of cooperating aircraft, while also offering policymakers tools for escalation management, since unmanned strikes or reconnaissance can send strong signals without the political risk of pilot casualties. With the first flight of YFQ-42A, U.S. Air Force is taking the lead in this direction.